Principles of Finance with Excel Modeling, copyright Lou Gaddis. Topic 4, NPV and IRR. Net present value, NPV, and IRR, internal rate of return, are measures used to evaluate investment decisions. They are used to ensure that an investment's return will exceed its cost of capital and create value for the firm or individual. In this topic, we'll apply NPV and IRR techniques to evaluate personal investment decisions. So let's start with NPV. The net present value is the total present value of a given set of cash flows. So the NPV is the sum of the first cash flow received today or paid today, plus all the subsequent cash flows discounted back at some interest rate, which we'll call the discount rate. Once you calculate the NPV of an investment, you accept all investments whose NPV is greater than 0, which means that its rate of return is greater than the discount rate or the cost of capital. So let's calculate the NPV of our first project. So our first project has a discount rate of 8%. We'll assume that's our cost of capital for this project that reflects the risk of this investment. And the first project A has these following cash flows. Pay $500 today and receive the following cash flows. So we can calculate the present value of each cash flow by taking the cash flow divided by 1 plus the discount rate, I'll anchor that, raised to the t power. Now the first cash flow is received today, so the present value of $500 is $500. And by taking anything to the 0 power ensures that it returns the initial value. Because in effect, what you're doing, you're taking 500 over 1 plus a discount rate to the 0 power. Anything to the 0 power is 1, so it's really just $500 divided by 1. I'll then copy that formula down. And what we see is the sum of all the cash flows is the net present value, which in this case, the present value of cash flows 1 through 5, excluding the first one, was $494. But we paid $500 initially for this, so it had an NPV of negative 5.25. Now, we also could have just used the Excel's NPV function. So we say equals NPV, put in a discount rate, I'm going to anchor that, comma, now put in value 1. Now notice it says value 1 and not value 0. So we want to start with the value received at the end of the first period. Now that will give me, if I just hit enter, that's just the present value of the cash flows from year 1 to 5. Then to calculate the actual NPV, I need to take the initial cash flow. So Excel's NPV function is really a misnomer. In practice, the NPV is the present value of all future cash flows from 1 to n, where n is the last period, and the initial cash flow. So NPV is really the sum of Excel's NPV and the initial cash flow. Now I could take that formula and I'll copy it here and calculate the NPV the second. But let's do this one by hand. $500 today divided by 1 plus the discount rate, I'll anchor that, raised to the 0 power. I'll copy that down. This is the present value, the value in today's dollars of all the future cash flows. The sum of the first cash flows 1 through 5 in present value terms is $543. You pay $500 initially for this investment or project, so the NPV is 43. I could also just use the NPV function where I specify the interest rate, cash flows 1 through 5, and then add the initial cash flow. So in this case, we would accept project B because it creates value, which means that its return, the investment's return on its $500 investment is greater than its discount rate of 8% or its cost of capital. Project A, on the other hand, its return must be less than 8% and therefore will not do the project. So that's NPV. Now what we'll do is calculate something called IRR, the internal rate of return. Now the internal rate of return is very much related to NPV. In fact, the IRR is simply the discount rate that makes the NPV equal to 0. So in some sense, it's kind of like the break-even discount rate. So if we specify our cash flows, our initial cash flow 0, and then set up a formula that the initial cash flow plus all the subsequent present value of all the future cash flows is discounted as some rate R. That some rate R, in this case the IRR, is the one discount rate that makes the present value of all cash flows 0. So we can now go back to our Excel model. Now we could start with use a goal seek. I could just say for project A here, I could say data, what if, goal seek. I could set the NPV to a value of 0 by changing the discount rate. And what you see is it's 7.67%. At 7.67%, this project has exactly a 0 NPV. But I'll hit cancel. We can use our IRR function, equals IRR. Just put in all the cash flows, not the present value of cash flows. It's very easy to make that mistake. And I get my 767. I can then copy that formula over here and see that the IRR of the second project exceeds the cost of capital 8%, and that's 1217. I can prove that this is the IRR by, if I change this to 1217, notice that the NPV of the project goes to 0. So that is the internal rate of return. You can think of the internal rate of return as the rate of return on the initial investment, in that case our $500. And the way we'd use the IRR to evaluate projects is you would accept any project whose IRR exceeds some reference rate, which we'll call a hurdle rate, which is often used as often is used for that rate is the cost of capital. So back to our example, if our cost of capital is 8%, that's what it costs us to borrow money to invest in these $500 projects. As long as our IRR exceeds that rate of return, that 8% hurdle rate, we'll accept the project. So, and again, in this case, we'll accept project B because 12 is greater than 8. We'll reject project A since 767 is less than 8. Next thing I want to talk about is another way of calculating NPV and IRR. So we're going to look at an investment that costs $13,500 today and returns $1,000 every 90 days or 3 months for 20 payments, in other words 5 years. Well, I'm going to show you the danger of assuming annual year-end payments, and then we're going to actually do this, calculate this NPV using actual calendar dates. So we'll go to our spreadsheet and say that if we spent $1,350 today and got $1,000 every 3 months for 5 years, that would be $4,000 a year. But for simplicity, I'm going to anchor that right there. For simplicity, what if we just said that we just received a year-end $4,000? So annually, the cash flows would look like this. And then if we calculated the IRR of the investment, I'd get 1471. And if I calculate the NPV, equals NPV, I'll assume a discount rate of 16%, comma, and I'll put in my cash flows from period 1 to 5, close that off, and then add the initial cash flow with time period 0. I get an NPV of negative 402. However, we remember that the cash flows are every 90 days. We just, for simplicity, assume they happen at the once a year. And when you calculate the NPV and IRR, it assumes year-end payments. So let's say the first cash flow is in 12/1 of 2016. So I can type in 12/1 2016 in Excel, and then I can take that and add 90 days. I'll make sure that the format is set to date. And what Excel will do is it'll increment that date by 90 days. And if I copy that down, these are my 5 years of cash flows from years 2016 to 2021 every 90 days. Now, initial cash flow is $13,500. And then we're going to receive $1,000. I'll take the $1,000, anchor that, divide it by 4. Because you're receiving $1,000 every quarter for 20 years, or for 5 years. So that's what the cash flows actually look like. Now, Excel, if you have dates, Excel has something called the XIRR and XNPV that uses actual date timing. So I can say equals XIRR, put in the values of the cash flows. It doesn't matter if you start IRR at the period 0 or period 1. It can accept either, because really all it's doing is calculating a return on the initial investment. And then it says dates. And I get an IRR of 1759. So now this one exceeded the cost of capital, and now we'll accept it. And then we can calculate the XNPV. We'll put in the annualized discount rate, all the values, and all the dates. And notice that if we just assumed annual payments, it says that we'd have a negative NPV of $402. If we use the actual date timing, we actually create value of 424. So this is the danger of trying to assuming annual payments. So if you do have a project that's on the edge there between accepting and rejecting, you might want to actually figure in the actual payment dates and then calculate the XIRR and XNPV. Now let's do an example. Suppose you want to buy a condo and rent it out. You want to calculate whether is this a good idea. So the cost of the condo is $100,000 today. Your tax rate, your personal tax rate is 30%. You expect to have $24,000 a year in rent. Property taxes are $1,500. You can subtract those from your tax bill. Other miscellaneous expenses you can subtract from tax bill is $1,000. You're then going to depreciate the $100,000 over 10 years. You're going to calculate your income before tax, subtract out taxes, and get net income. We'll then convert to cash flows. And then we'll decide whether or not this project exceeds our cost of capital, which we assume is, say, 12%. And then calculate the IRR of this investment. So let's go to our spreadsheet. So our rent is $24,000, property taxes of $1,500, miscellaneous expenses of $1,000. I'm going to amortize my $100,000 over 10 years. So I'm going to amortize $10,000 a year, and the IRS allowed me to recognize that as an expense. That'll give me, I'll sum that up, an income before tax of $11,500. I'll then take that times the tax rate, and I'll pay $34,000 or $34.50 in taxes. I'll then take my earnings before tax and my taxes and get a net income of $80.50. Now again, remember, to make any investment decision, we need to know cash flows. These are reported net income, but in that reported net income, there's this expense of $10,000, which was not real. And there's also, it didn't handle the fact that we actually spent $100,000 today. So the first thing I want to say is, if I'm going to do an NPV or an IRR over here in this column, I'm going to then first subtract out my $100,000 expense today. Now let's figure out what all these cash flows look like. Let's start with our net income. Our net income after tax is $80.50, but in that net income was $10,000 of expense. That was not a cash flow expense. So my cash flow is actually $18,050. So this is similar to what we've done before, except before we had annual CapEx. This is my CapEx right here. And before we had working capital. In this example, we'll assume there's no working capital. So my cash flow is $18,050 as our operating cash flow per year. So I'll anchor that and copy it down. And assuming that the condo is worthless in the end of the year, at the end of 10 years, we can calculate an NPV. So I'll do an NPV where I put in a discount rate, anchor it, comma, your cash flows 1 through 10, close it off, and add the first negative investment there. So I get an NPV of $1,987. I can also calculate the IRR of my cash flows. So it looks like this project has an IRR of 1248, which just exceeds my cost of capital, my discount rate, and it creates a present value of 1986. So it looks like the project's pretty good. So the one assumption is kind of silly, and that is the condo is worthless at the end of the 10 years. We can make one other assumption. Let's assume that at the end of 10 years, I'm going to sell the condo for $80,000. Now at the end of the 10 years, the condo is fully depreciated. So in other words, it has a book value of 0 since we amortized over 10 years. So when we go to sell this condo at the end of the 10th year, it has no book value recognized, so it has 0 book recognized by the IRS. So this $80,000 is fully taxable if we sell it at the end of the 10th year. So what we can do is take the same example. These are the exact same cash flows before, except for the final cash flow. The final cash flow, we're going to get $18,050 of that last year. Then we're going to sell the condo for $80,000. However, we're only going to be able to keep 1 minus the tax rate. So our final cash flow is going to be $74,050, which is the final operating cash flow of $18,050 from our rent and expenses, plus the fact that we sold the condo for $80,000 and paid taxes on the full amount since it was fully depreciated. Now, if it wasn't fully depreciated, I would only be taxed on the difference between the sale price, that was salvage value, sometimes we call it, and the book value, where the book value is its cost minus how much has been depreciated. And we'll talk about those examples another time. So the condo looks like even a better idea, right? A better investment. It's going to give me a 16% return. And that should just say was salvage, by the way. It's not early salvage. We sell it at the end of the 10th year. And it has NPV of $20,000. So one way of thinking about that $20,000, we spend $100,000 today, and that project, the present value of all the future cash flows, are $20,000 above the $100,000. Another way of thinking about it is I should have been willing to spend $120,000 for that condo. And we can do a little sensitivity analysis. We can do a sensitivity analysis on the IRR. So I'll do a link to the IRR. And I look at rents from $18,000 to $28,000 per year. And I look at salvage values from $50,000 to $160,000. I'll just highlight this table. Data, what if, data table. Now the row is rent. I'll find the rent that's linked to the IRR. There it is. Well, let me start that over again. So data, what if, data table. Find the rent. That's linked to the IRR, and find the salvage value that's linked to the IRR. And then what I can look at this is a sensitivity analysis. It looks like this project will give me a return of between 9 and 21%, where the best case is when the asset has a higher resale value, the condo, and when the rents are higher. And if we look at a break even of about 16%, you can see where the project becomes a negative NPV, or it doesn't meet our hurdle rate of 16%. I'm sorry, 12%. So that's how we can use NPV and IRR to invest, or to look at a condo investment. Let's do a note. In the case they're going to be assigned from this section, we're going to look at a similar example as this little condo case, except in this one, you're going to calculate the interest and principal payment in each, because we're going to finance the purchase of a condo with a loan or a mortgage. So let's just talk about how to do that. So you're going to borrow $100,000 to buy that condo, and you're offered a 12% annual percentage rate loan for 30 years and pays monthly. Well, the total number of payments then are 360. And the monthly interest rate is 12% divided by 12. So it's really a 360-month loan at 1% a month. So we can calculate the payment of that loan, the periodic rate, comma, the number of periods, comma. I'll put a negative present value and hit enter. And I put negative present value because if I didn't, it would just return a negative 1028 as a payment. So I like to look at payments as a positive number. So my monthly payment would be 1,028. Now we can also use the principal payment, the P payment, and the I payment functions. Because this 1,038, this is a level payment over 30 years. However, each payment is going to be composed of both the repayment of principal and interest. And over 30 years, you repay all the principal. However, in the early years, most of the payment is in interest. And in the end of the period, most of the principal or most of the payment is going to be principal. So what we can do is we can say equals P payment. There's my monthly rate, comma. Let's look at payment number 5, comma. There's 360 total payments, comma, and the present value of the loan is $100,000. So what that says is the 5th payment is going to pay off $29 of this $100,000 loan. Now I'm going to anchor all that by highlighting the whole cell, hit F4, and copy it. I'll then go ahead and change the name of it to I payment, because I know I payment actually has the same parameters. And you can see that in that 5th payment, $998 of the 1,028, that's just a sum, is interest. However, if I look at the 360th payment, 1,018 of it is principal and $10 is interest. So this allows you to figure out each payment, how much is principal and how much is interest. And this becomes important for the case that we're assigned on this in this particular topic, because interest will be tax deductible as an expense, but principal will not. So if we're calculating free cash flows with loans, and we're looking at free cash flows to equity, so free cash flows to the owner is going to first subtract off interest payments. In that case, we can only subtract the $998 to calculate earnings before tax, and not the full mortgage payment. Let's do another thing with NPV and IRR. Not a real common one, but let's say you won the lottery. And in 2014, a South Carolina lottery winner was given a choice of a lump sum of $223.7 million today, or a 30-year annuity starting today at $7.1 million, and the annuity will grow at 4% per year. So the question is, what should he do? Let's assume that he can invest risk-free at 3%. That's going to be our discount rate to compare these projects. So let's take a look at this analysis of this lottery winner. So let's say the choice is a lump sum of $223 today, or you get an annuity that starts at 7.1 million and then grows by multiply times 1 plus the growth rate, and I anchor the growth rate. So this is what my annuity looks like. This is what he's going to get for 30 years starting today. Let's change that discount rate back to 3%. And now we can calculate the NPV of the lump sum is 223, right? The present value of a payment received today is 223. I don't have to prove that. However, the NPV of this investment, of these sets of cash flows, so I need a discount rate, comma, all the future cash flows starting at the period 1, plus today's cash flow. So my NPV is 246. So it looks like the NPV, the present value of all cash flows, for the annuity is higher than for the lump sum. So it looks like they should accept the annuity. Now this example is kind of interesting because it allows me to think about what it really means to have a higher NPV. So let's do this. Let's actually take another cash flow. Let's take a difference. Let's take a cash flow, which is the annuity minus the lump sum. So this would be modeling. What is the incremental cash flow if I go from choosing the annuity, or go from a lump sum to an annuity? So it's really the cash flows for the annuity over the lump sum. And I can calculate the IRR of that investment of going from the annuity, from the lump sum to the annuity. So you can think of the IRR of going to the annuity as 365. And we can calculate an NPV. I'll put in my discount rate, 3%, comma, all the cash flows from year period 1 on. Let's grab that period 0 cash flow. And looks like there's my 2219. So when you take a difference, say annuity minus lump sum, and take an NPV and IRR of that, it's really the NPV and IRR of choosing that first one, the annuity. Now let's talk about what that actually means. Let's assume that it looks like you want to choose the annuity. But let's make a change here. Let's assume that you choose the lump sum. If you choose the lump sum, you'll get 223 today. But let's pretend you choose the lump sum and then you pay yourself the annuity. So I get 223, then I immediately withdraw, and I put that in an account. All right, I put that 223.70 in an account, and then I immediately withdraw today 210 or 710. Now I have 216 million in my portfolio, in my savings account. And say that account gives me an interest rate of 365. So next year, that 216 is going to earn 365. Let me anchor that 3.65. That gives me 224 million. But then I withdraw my annuity. I withdraw my 738. So what I'm doing is I'm building my own annuity by taking the lump sum of 223 and withdrawing 710, then withdrawing 738. I can build my own annuity. And what the IRR actually means, the IRR of this column says it's 365. What that means, if my discount rate were 3.65, and I'm just going to copy this as a value, copy Alt HVV and paste it as a value. Notice that I'm indifferent between the two at a discount rate of 365. And notice what happens to my portfolio. It is perfectly set up such that my last withdrawal is exactly equal to what I had in my account at the end of the year. So what this means is if I can invest at 365 risk-free, I would be indifferent between the lump sum or the annuity. However, if I can only invest at 3%, let me just plug in 3 there. Notice I have a shortfall. That's why the annuity was better. Because if I can only invest at 3%, I wouldn't be able to recreate that annuity. So the NPV and IRR are powerful tools that allow us to think about any investment decision, corporations and personal. Last thing I want to do, let's calculate an NPV of a residential MBA program. So you're 24 years old today, just happy birthday, and you're considering a 2-year full-time MBA which costs $200,000 per year after fellowships. You're going to start today, so you'll be done in 2 years. You're currently earning a salary of $65,000 per year. We'll say that's what you're going to make by the end of this year, and that grows at 3% forever if you don't get an MBA. Now, after the program, MBA program, you expect to get a job that earns $95,000 a year that grows a little bit higher, 4%, and you plan to work till age 65. And we're going to use a discount rate of 6%. What is the NPV and IRR of getting an MBA at the young age of 24? That seems like a little young, but let's try it. Let's say there's no cash flow today. Let's say if you don't get an MBA, you're going to get a salary at the end of next year of $65,000. That salary is then going to grow at 3%. I'm going to anchor that. So I don't do my MBA. I happily earn these salaries that grow at 3% forever, ending at $212,000 when I retire. Now, if I do get an MBA, I'm going to spend $20,000, we'll assume at the end of the first year, and $20,000 at the end of the second year. We'll just make everything year-end payments to make things simpler. Then, when I graduate, I'm going to get a job of $95,000. And that $95,000 grows at my MBA salary growth rate of 4%. And let's actually change this. Let's assume our discount rate's 4% for now. So that's my discount rate, and that's also my salary growth rate. Now that discount rate could be... So we'll calculate our incremental cash flows. If I take the MBA minus no MBA, that's my incremental cash flow. So the first year I'm really losing out on $85,000 because I foregone $65,000 in salary and I paid $20,000 in tuition after fellowships. So these are my incremental cash flows. Now what I have in here, we can calculate the NPV of no MBA. So if I'll get a present value of lifetime earnings from years 25 on of $2.1 million. I'll do incremental cash flows from year 1 through or 25 through 65 if I get my MB of 3.2 million. Now if I calculate the NPV of the incremental, it's also just the subtraction 3.2 minus 2.1. So it looks like you create $1.1 million in value in today's dollars by getting an MBA using these assumptions. And you wouldn't expect me to give you any assumptions that wouldn't give you a positive IRR NPV, but actually it's pretty hard not to get a positive NPV and IRR from getting an MBA. Let's now calculate the IRR. I'll take my first cash flows there, $85,000, and calculate my IRR of my investment, 19.85%. So it looks like a great deal. So this is how you can make a decision whether to get an MBA. You can actually look at different programs. Maybe different programs have higher cost, or they have higher expected salaries. You can decide which is the best program. So next thing I want to do is do one more thing called a modified IRR. Now, a modified IRR is something used by a lot of companies, and it kind of, when we use it, you'll see it points out one of the flaws of IRR. Say a firm can borrow money, or I'm sorry, say the student who's getting their MBA can borrow money at an after-tax cost of 4%. So maybe they're using some kind of loan, maybe a home equity line of credit or something like that, but the after-tax cost of loan is 4% per year. And this extra money they get from an MBA, say all that extra money goes into retirement savings and they're going to put it in a portfolio that earns 7% interest or 7% return. So I'm going to borrow at 4% these amounts of money, and I'm going to invest this extra money at 7%. Now if I use IRR, IRR just assumes both of those are done at the discount rate of 4%. In other words, you're borrowing at 4% and reinvesting this incremental amount at 4%. But something called the modified IRR lets you decide what cost do you borrow money. We'll call that the finance rate. And what interest rate do you get on the positive cash flows in which you reinvest? Now the calculation of it is kind of interesting. The IRR calculates the present value of all negative cash flows at a finance rate, your borrowing cost. So it gets the present value of all negative cash flows financed at the borrowing cost. Now all positive cash flows, it kind of assumes that you go to the final year of your investment. Let's assume that you take all those and you reinvest them, those extra cash flows, and reinvest them at the reinvest rate. And you calculate a future value. So what's all the positive cash flows in year 65, and you have all the negative cash flows in today. And then what you do is you do this formula, the future value of all the positive cash flows divided by the present value of all the negative cash flows. In other words, the total value of my inflows at the final year over the present value of all my outflows over 1 divided by n. N is the number of years to the final cash flow, year 41 minus 1. That's the modified IRR. Now where this comes from, I can take this formula, rearrange it, and what you see is future value is equal to present value times 1 plus the rate of return to the n power. So IRR is really just solving for this r. What rate of return are we earning by comparing the present value of all my investments or my borrowings and the future value of all my positive cash flows? So now the easiest thing, we can just use the MIRR function in Excel, but I'll show you how it works. And we can do it first. We can say equals MIRR. It asks for the values. So we'll put in the incremental cash flows. Now the MIRR, I've found that the function must start at period 0. So even though the cash flow is 0, it must start there. Now the IRR has a couple more parameters, comma, the finance rate, that's the rate at which I can borrow money, comma, the reinvestment rate, that's the rate in which I'm going to reinvest all the positive cash flows. So I got a MIRR of 10.84%. Let me show you just how they calculated that. You don't really need to know this, but it feels good that you kind of know where it came from. In this example, there's 41 years till I retire. I'm at age 25, I retire at age 65. There's 41 years from now is when I retire. That's my investment horizon. So how I can do that? I can take the incremental cash flow, take the present value of all the negatives. So I take that, divide it by 1 plus my finance rate, anchor it, raised to the 1 power. So I'll take the present value of $85,000 paid next year. And I'll take the present value of the second one. And if I take the sum, I'll take minus the sum. In present value terms, I had to borrow $162,000 at 4%. Now I'll get the future value of all my cash outflows. Now this is a little tougher one to understand. This $26,000 on this investment, how much is that going to be worth if I invest it at 7%? And if I, at age 41, the end of a 41 year. Now this is received in year 3, so it's really 38 years from now. So I'll take that cash flow times 1 plus the reinvestment rate. Anchor that. Raised to the 41 minus, I'm going to anchor that 41, minus year 3. In other words, 38 years from now. So that $26,000 is going to be worth $340,000 when I'm 65. If I copy this down, these are the future values, the value of each cash flow when I'm 65. If I sum that up, sum all the positive cash flows at age 65, the value of age 65, there's the value of all my positive cash flows, the future value of all my positive cash flows in 41 years. Now if I take my formula, my future value divided by my present value, raised to the 1 divided by n power, 41 minus 1, that's how they get the MIRR function, the modified IRR function. And what you see is, well, if you had to actually borrow at 4% and reinvest at 7%, the IRR, the MIRR is 19.85%. So the modified IRR is used by many companies, and they feel it's a more realistic measure of rate of return that uses the differential between your reinvested cash flows and your finance rate. So if I were a firm, I'd probably use my weighted average cost of capital as my reinvestment rate, because all the positive cash flows can be put back in the firm. And maybe I'll use my cost of debt as my finance rate if I'm for that project, if that's what I plan to do for the project. So it has a differential in that project, you know you're going to finance it with debt and you know you're going to reinvest in the firm, you might do something like this. So that's modified IRR. So in this topic, we talked about NPV and IRR. Now, one problem is it's possible if we use NPV and IRR to say rank multiple investments. So you look at 5 different investments and say all of them are positive NPVs and all of them have IRRs are greater than the hurdle. However, you're only going to pick one or a couple or several of them. If this happens, you want to always you might get some conflicting rankings between IRR and NPV. If that happens, and in the general case, you should always use NPV to choose projects. And that's because firms and individuals, right, do not try to maximize rates of return. They try to maximize wealth, value, and NPV ensures that. So that's the last caveat. You generally like to use NPV. However, most firms calculate both. But if you get a conflict between the two, I would default to NPV. Now, on this topic, we talked about net present value and internal rate of returns as measures to evaluate an investment decision. If the NPV is greater than 0 and the IRR is greater than a hurdle rate, you have created value for the corporation or the individual. So, and now the next topic, when we get back together, we're going to talk about how to apply NPV and IRR to business decisions.